Hi guys, welcome to Learn Electronics Repair. I have another device from Fnirsi today. This is a flat panel oscilloscope multimeter signal generator, so it's another one of these 3-in-1 type devices. Again, Fnirsi sent me this to review, so I was sent this free of charge. But as always, I have total editorial control. I'm going to give an honest opinion of the device and see what I think of it. First thing first, let's have a quick look and see what we have. And the strange thing I noticed straight away is we have a funcation. Funcation. Not sure what that is. Is that a typo on the box or something? Let's see. So, quick product parameters. Dual channel scope. 250 megasamples a second. Sensitivity down to 10 millivolts per division. Oh, this has an XY mode, I've just noticed, so this will do like lithograph figures, that sort of thing. Maybe we can play with that. 50 megahertz bandwidth. Okay, signal generator up to 10 megahertz on sine, on to 5 megahertz on other waveforms. Amplitude up to 3.3 volts, that's fairly standard. Has duty cycle on square wave. Yeah, this is very standard. Multimeter up to 1000 volts DC, 750 volts AC. The lowest range looking at this, it has the 5 digits, so this will measure down to, according to this, 100 microvolts, same on AC, and down to 1 microamp. So it has a reasonable range, it has a 10 amp current range, pretty much what we'd expect really. Let's have a look at the item itself. Let's unbox this, okay? So, instruction manual. This is quite chunky actually, it's quite heavy as well. You certainly know you've got something in your hand here. This is not like, sometimes it feels like a box full of fresh air. There's some weight in that, surprisingly actually. Screen protector, so we have the screen, nice and clean obviously. USB, power switch, yeah, these are your scope probes. Oh, this is the output from the signal generator, which uses a different type of connector. I wonder if we get a lead for that with it. And your connections for your multimeter, okay. Normal thing, volt, ohms, diode, capacitor all on one, and temperature, common, milliamps and amps. Let's see what leads they give us with this. Well, we have 2 oscilloscope probes. These look very standard, the normal type we have. These should be good to 100 megahertz. That should be fine for this scope. We have 2 meter leads for the multimeter. These are the sharp pointy ones. Oh, they are like the sharp needle ones. That's good, I'll give it a bonus for that. Normally you have to buy your own leads, but you can probably use these out of the box quite well. And yes, a connector for the signal generator. So we do have a connector for that at least. Fits in quite positively actually. Yeah, okay. So that's what we have. We don't have a power supply though. So this is USB-C. I'm guessing they're thinking these days everybody has a USB-C lead, but up to you what you think. I think if you buy something, it should come with a power supply at least. Okay, and we boot it up. Touch screen. Oh, that's nice. And we have a funcation still. Where's this funcation? Oh yeah, it's all touch screen, this thing. Settings, multimeter, scope, signal generator. Okay, I obviously touched on something then and went into the menu without even realising it. Yeah, this is moving me around menus. So yeah, menu button takes me back to here. Settings, multimeter. So what is this funcation? Well, it doesn't seem to do anything at the moment. Maybe it does something when we go into one of the devices. So first off, let's just try the multimeter. What I don't see on the screen, by the way, is a battery signal. Oh yeah, battery. So I do have a battery level. It's there. I just get that once I actually go into one of the functions. Oh, look, and this is showing me where to attach the red lead, and I assume that means the black lead as well. Let's see, can we just change to a different... No, the funcation still doesn't do anything. Oh, gear. Yeah, that's mode. I would call that mode, not gear personally. I would call that mode. Volts. Yeah, continuity. We can see if this passes the Mr. Bleep tester or not. Capacitance, milliamps, for example. Oh, I see. It made a click and then it changed this, so it's now showing us. So, yeah, the grey one is effectively your black lead, and then the red one is your other lead. So let's have a quick go again. Amp should move to the bottom one. It does. Yes, that's quite nice. It shows you where to put the lead in. That's fairly good. Oh, we have a little graph here. Look, and it's doing something. What is that doing? I mean, there's nothing... going in the way of a signal, but that showed me something. That's strange. Okay, well, as I say, let's try the multimeter. Oh, look, it's just doing it again. So that's the first thing I've noticed about this strange behaviour with this, yeah. Does it do that only on the microamps range? Maybe it's picking a bit of stray interference up. Volts. Gear. That's interesting, actually. When you change mode, it's like you have to press gear again. We press and hold. Okay. I don't really see why I'm asked to press a button twice. I mean, if I press the ohms, I want ohms, yeah. Just a little niggle that, but I don't see why I need to press a button twice to select something. Oh well, let's try it anyway. You'll notice as I'm plugging in the leads, this graph is doing like strange things by itself. Short them together, it stops. You'll also notice, I hope, that this screen is really bright. Very clear, I'll give it that. Okay. We'll just put the bench power supply on, nothing special. I don't have any exactly accurate voltage references here. I probably should build myself something, actually. Coming to think about it, that could be an interesting project and useful. So, having had that good thought, we'll use my bench power supply. 5.3 volts. I mean, it's within one digit, okay? It's very responsive, actually. It's responding quick to the change. And I've noticed this graph here scales to match the voltage, but it doesn't really give you any, like, scale, you know, per division. But what it does tell you is what the maximum and minimum reading is. I'm guessing you can clear that. I haven't looked at the manual. Okay, I've figured out actually you can reset the scale, but you can only do it by effectively changing into the gear thing and back out again. But you need to choose another range. And that then resets this, or rather the range of it, yeah? I see that this scale thing here is fairly fast. So, just a quick look at the multimeter. Let's try the usual things. Let's try the diode mode and the resistance and the continuity. Does this pass the Mr. Bleep test? First then, the resistance. So, gear, ohms. You really should get... Yeah, I'm not going to say anything else about that. But you should just change, okay? So, low value resistors. A lot of multimeters struggle with this. This is a 0.22 ohm resistor. You probably can't even see it. Yeah, probably see it now, okay. So it's like a dual resistor, so 0.22 and 0.44 across the whole length of it. Let's have a look. So, well, it reads 1 ohm. I mean, that doesn't read. Can we set the range on this so we're not into auto? Again, I've had a look at the manual and I don't seem to have any option to set this to manual range, which I find, why not? Yeah, why not? So we can try shorting the leads. Well, it's not reading 0. It doesn't seem to have any option to calibrate that, but never mind. I mean, sometimes meters won't do that. We can say, okay, with them shorted, it's 0.3, close enough. So measure our resistance and take 0.3 off. Let's have a look. No, that's telling me that is a 1 point, near enough a 1 ohm resistor, not far off, and I would consider that probably to be faulty in an amplifier and take it out and have a look. This should give me 0.4. Okay, so across the resistor is giving me 1.27. That's a 0.44, and across the middle 1.07, 1.1. It's telling me that one is about 0.2 more than the other, which is fair enough, but it's just not giving me a very good reading, I'm afraid, on that one. A lot of multimeters do struggle with that, but they usually show them as being short. Here we have a 100 ohm resistor, and that's reading very close. Although it's on auto range, it's pretty fast actually. This should be a 10k. Yeah, close enough for me. I'm not sure if this does anything useful, this thing at the bottom. And this one is a 10 meg. Yeah, these usually read about 11, and they read that on my other meters as well, so that's not the meter giving me a bad reading. If I measured that on my Fluke, and in fact we'll do the low resistance while we're here as well. So ohms range, this is the 10 meg again, that reads about 11. And you can see it's no different. Okay, let's just check the low value resistors. Okay, so this should be 0.44, reads about 0.8, and this should be 0.22, about 0.7. But I can go into the low resistance range, short, hit the button. Okay, that's reading 0 now. We'll just read this accurately, so 0.22. Well, no, actually it reads as a short, and 0.44.2. So, as I say, multimeters, generally speaking, are not very accurate on low ohm resistors, even my Fluke. Okay, we'll try the all-important continuity and diode test. Okay, so gear. They're both on the same range. It's like just one range, so they're both together. Diode. Oh, this is giving me an option. You see here, so I have like a little diode symbol. Touch it. A continuity. Back. So you can switch between those two without hitting gear again. And I didn't mention it, but on volts, Luke, we can go the same DC, AC. So this does make me wonder why it wants me to press gear again when I choose one of these options. Still, okay, we're in diode test, so let's try it, and then we'll try the continuity. This is a standard 1M4007 silicon rectifier diode. Let's try it. So it reads the junction, the voltage drop, as it would, as it should, but we don't get any blip. There's no sound. Mr. Bleep would tell us that we should get a single blip on a diode junction. This is a Schottky diode, okay? So I don't expect this will make a bleep either, but it should read lower at 0.15, 16, something like that. Yeah, 0.17, just what you would expect for a Schottky. Can you change these with the probe? No. Continuity. Oh, that's loud. That is loud. So the bleeper responds very quickly. The display doesn't, but that's not unusual. And it won't read 0 on a short, and I can't find any way to calibrate that either. Okay. unless I'm wrong, but I can't see any way mentioned in the manual to calibrate that, and that's quite some way out. Just make sure the leads are actually pushed in well. Okay. Yeah. That would concern me to some extent, to be quite honest. In fact, it does. With capacitance, according to the manual, this should read down to, let's see, 9.999 nanofarads. So that's like 1 nanofarad, basically, resolution. So this is a 12 picofarad capacitor. Will it read it? Well, it says it's, yeah, I mean 22 picofarads, yeah, 0.022 nanofarads. So that actually reads that quite nicely. I read it a bit high, but it's probably not very accurate. I mean, these are ceramic capacitors. I can just try that on my capacitance meter actually, just to prove it. So I actually have 2 of these. I'm not sure this is the same one. Let's go again. 23 picofarads. Okay, meter is 0. Let's try it. Well, that reads about 9, so neither of them read particularly accurately, but they both read it. We'll go for something more common, like a 100 nanofarad. Okay, these capacitors usually read quite a lot lower, about 60 or 70. 65, yeah. And this is a large capacitor, so with most of these multimeters, if you measure a large value, this is a 3300, it's going to take a while. Let's have a look. Oh, that's pretty quick actually. Again. Yeah. Not so bad for a multimeter. Okay, the last thing I'm just going to check on this is current. So we'll go into the amps range first. Like most multimeters, this will have some sort of time limit on high currents, but we'll just try it. So my bench power supply can give me 5 amps maximum. Yeah, I'll turn the current range down for now. Give it some voltage. Doesn't really matter what voltage I set because it's the current which will effectively set it. Okay. Let's just short the leads together. So that's just giving 50 milliamps. You can see that. Let's connect it to the multimeter. A good spark. 50 milliamps, and this is saying 50 milliamps. Turn the current up. Yeah, 1.28, 1.2, very close actually, just up to the maximum I can get in. 4.95, 4.96, so quite happy with that. And now we will try the milliamps range. So most often when I'm doing this, I probably want to check something like the draw on a CMOS battery from a motherboard. This tells me a lot about the state of the chipset. So we have there one motherboard. Okay. I would expect this to be drawing somewhere between about 1.8 and 10 milliamps max. So quite simple to do this. First of all, we want the lead in the right slot. It's telling me that. Okay, it's actually telling me. Okay, milliamps. Red lead to the battery, then we push the clip back with the black lead. And we expect about, well, I'm not quite sure what this board is. It's a couple milliamps or so. Sorry, a couple of microamps or so. And it doesn't show anything. Well, I have the leads in the right slot. Okay, it does, but it's like giving me, I'm expecting 1 or 2 microamps. Let me check it with another meter. So this is the one I normally use. It's the most sensitive one I have, microamps range. Okay, same thing. Yeah, 1.94 microamps, okay. And this is not an expensive multimeter. This is an Aneng AN8008. I think the 8009 now is the newer model, but the equivalent of that. So it's not expensive, that thing. Try again. No. And I definitely have the lead in the right slot. So that was a bit disappointing, really. I mean, that's a fairly common real life usage. Not all my multimeters will do that, by the way, but the Aneng wasn't expensive and it'll do it. So, multimeter, yeah, it's a multimeter. I like the bright display. The display is very nice, but it doesn't really do all the things I'd want it to do. So, it's okay, depending on what you want to do, I guess, but that's about the best I'll say for it. I do find it annoying that I have to press this gear button to change range. That's the temperature of the device, by the way, 34 degrees. Not the temperature of the room, which is about 26.5. Well, I can't plug a standard thermocouple into it, and that's a standard one. I can try this. Not sure which is a positive end, let's find out. Other way. Doesn't really seem to do anything particular. Maybe I'm using the wrong, oh! It is actually, it's gone down to the room temperature. I think maybe I have it connected the wrong way around. Yeah. Okay, that actually works fine. You just have to wire up a thermocouple with 2 of the 4mm plugs on the end. Or you could probably buy them like that as well. Okay, so the signal generator is actually really quite nice and easy to use. I think because we have this touch screen. So we can choose a waveform. You can see on my oscilloscope there, it's displaying nicely. Okay. 2.016 kilohertz. This is set to 2 kilohertz. If we want to change the frequency, we just type it in. So 1000. Oh, I put too many. That's 10 kilohertz. And then we press the OK button, and it changes the frequency. Run, stop, switches it on and off, and then we can touch the little icon here as well. Well, that doesn't seem, yes, that does also turn it on and off. Okay. Amplitude, again, just type something in. 3.3, I think, is maximum. Well, actually, in the manual, it says 3.3 is the maximum, but it's 3 in actual fact, okay? That's common for signal generators, but there was just a discrepancy in the documentation there. On the back of here, it definitely says to 3.3. Unless that depends on the type of waveform. Let's hit the square. So we can touch on the slider as well. No, 3 is definitely the maximum. You can't go above that. So you can either type in the value or you can use the slider. So duty cycle, for example. We can go, say, to 25%. Okay, we have a 25% duty cycle. And then we can also move the slider. So this is nice to make quick changes. It's a little bit fiddly to get an exact amount, but you can type it in. Okay, so you have 2 ways of doing that. That's fine. Sawtooth, a half wave. What else do we have? We have some arrows here. A full wave. I just altered the trigger on the scope. Okay, it's triggered. A step waveform, up, down, a DC level. What else do we have? Multi-audio. Oh, that's kind of like, I'm guessing, a bass and some higher frequencies mixed together. Interesting. I wonder what that sounds like. We also have sync pulse, by the way, which is that one. That's spelled like sync, like as in like a kitchen sink. Is that what he means, or should it mean like sync as in synchronization? I don't know. Multi-audio. So I'm on 10 kilohertz. I'm going to change this down. 1 kilohertz. Okay. I have my speaker lead here, so let's have a look. Just see what it sounds like. It's good and loud, I'll give it that. So, I think the function generator has quite a few different options. Oh, index up, index down. Yeah, it's a different waveform. This is like a charge and discharge or a capacitor type thing. So that's all the waveforms. You have quite a lot to go at. I have to say, the function generator does seem rather well featured. What's the maximum frequency? 10 megahertz. Okay. And let's go to something like a sine. Yeah. Quite nice. I have to say the function generator seems to work really rather well. The square wave isn't very square at that frequency. I didn't totally expect it to be, but yeah, that's not bad. And now we'll try the oscilloscope. The first thing I notice on the scope is that the colour of the trace is a bit unusual. So you would normally have like a cyan and a yellow, and they're not. They're like a cyan and like a sort of silvery, sort of very pale blue colour. But we can apparently change this one in the settings, so let's have a look. So go to menu, settings, touch it again. Yeah, we're in there, language, brightness, sound. Start up on boot. So you can tell it which mode you want it to go into on boot, or we can just go into the menu, okay. And we have this theme, so let's choose the other theme, okay. And then we'll come back out of here. Yeah, and now we have like a cyan and yellow, which is what I would expect to have on a scope. So that's normal, basically, is what we would normally have. I'm going to use my signal generator. So I'm going to try this at some higher frequencies, see how well it works. I'll compare it with my Rigol scope. So the Rigol is also a 50 megahertz scope, which means we have a basically good comparison, really, on the rated frequency range. Okay, so I'm in oscilloscope mode. I've attached my signal generator, so this one is at the moment set to 7.2 megahertz. It's a little bit flaky, this signal generator. It's a little bit noisy with the signal because it's just effectively a PCB on the bench from a project I built. Really needs to put it into a metal enclosure, but that will affect both scopes in the same way. So the Rigol is showing me 7.2 megahertz flicking on and off slightly, but it is telling me. On this one I can see a waveform, so I'm going to press auto. It now says awaiting auto measurements, and that's also giving me a waveform that basically looks the same as the one on the Rigol. Now I find out what the funcation button does. It's the menus in the scope. So we have measure, channel 1. I'm just using a single channel at the moment. Frequency. Okay, and we will go for amplitude. We have channel 2. Yeah, so channel 1 or channel 2 shows the colour. So we'll go frequency and amplitude on here. Okay, menu. Yeah, and this also now, this is telling me this is run at 11.46 megahertz. whereas the Rigol is telling me correctly. It is flicking on and off a little bit, but they're 7.2. Okay, let's go up in frequency. Let's go up to 15, 17, 27. We're on 27. So the Rigol now shows me it's 27 megahertz. It's managed to just stay on that basically. Okay. This one is telling me 11.46, so it hasn't changed. It's also telling me the amplitude is 5 volts, and this one is telling me it is 3.9. I'm not sure which is actually correct, by the way. So I have to hit the auto button again. It's now showing me a really weird, like, modulated waveform. This is a run stop, by the way. I had it on stop before, which is probably why it didn't change. Hitting run stops now changed it. Auto measurement again. 1.5 megahertz. But it's stable. I can move it around. I mean, I like this part of it, but I hit in the run stop, but it's changing. You know, I have to say, guys, this scope behaves in a really kind of like a flaky sort of manner. I'm not really sure what it's doing. 5 megahertz, 10 megahertz. Yeah. Let's go up again. So I'm now on 28.4. So as I change the frequency, the Rigol just changes. That's 50. But this doesn't seem to do anything. Auto. 1.85. I'm on normal auto trigger. Don't see anything strange there. Auto. And now it's not got it at all. Now it has got something. I'm not sure what it's got. Again. Now we have, and now we actually have it. Oh, and it's gone to 0, but we actually have it now. It's saying 27 megahertz and it should be 50. So this just doesn't really seem to work in any stable manner. I have the same signal into both scopes. So I have to say, guys, this is not really behaving how I would expect it to behave at all. Let's go up some more. I mean, this scope Rigol is a 50 megahertz scope. It's not being modified. It says 50 megahertz scope. I've now gone up to 100. What does it think of it? Well, in fact, it has locked on there and saying 100 megahertz, although that's twice the rating of the scope. Okay, the waveform is quite small. What does this thing think of it? Well, again, it's actually locked onto it. And it thinks it's about a kilohertz. But they will both actually show a signal, interestingly enough. But I think there's just too many strange quirks with this thing to really justify me going further with it, I have to say, guys. I'm back down at 7.2 megahertz now. Okay, both stable, both sort of showing the same sort of thing, but this one will not read the frequency. And that's well within its range. So this one, I've reviewed a lot of Fnirsi stuff and other brands as well, and mostly I'd say, given what the item costs, this one's about €100. They're pretty good. And also what the Fnirsi stuff is very good. I reviewed a soldering iron just a few days ago. It was excellent. But this scope, it's just too flaky. It doesn't really do what you'd expect it to do all of the time. And when you're repairing stuff in particular, for repair work, you need to be able to trust what this is telling you. And I have to say, sorry Fnirsi, but I can't trust this one. So you guys make your own mind up, but personally, there's many other Fnirsi models that work better than this one. Just to start off, never mind other brands, okay? Fnirsi make a lot better scopes than this one. Okay, hope you enjoyed that anyway. I did say I'd be very honest, and I think I have been very honest about this. I'll put a link to this product in the video description, of course. Fnirsi give me a link, I'll certainly put it in there. But this is not one I can personally recommend. If you've got one of these and it's working better, or if you think I'm doing something wrong with this review, certainly let me know, and I'll tell you what, I'll come back and review it again. Hope you enjoyed that, and I look forward to seeing you all soon on Learning Electronics Repair. Ciao for now, guys.